In recent years, there's been a rise in organised crime against high-value moving vehicles and their cargo. For example, the huge increase in piracy at sea has never been far from the headlines. As a result, there is a pressing need for an automated system to detect and recognise potential threats. ARENA is a security research project funded by the European Commission as part of their 7th Framework Programme and aims to address such a need.
The project addresses the need for flexible and affordable surveillance system for high-value mobile assets. This includes trucks, trains, ships and oil rigs. ARENA is unique as a surveillance system because it's located on the vehicle itself, and an alert is automatically triggered when potential threats are detected. The system focuses on scenarios where existing security solutions are limited. For example, a truck is most at risk while it is parked at the rest stop.
ARENA has brought together 7 different partners from across the EU, each offering their own individual expertise to the project. In order to achieve its aim of being an integrated, scalable and easy-to-deploy system, ARENA required a generic architecture to handle information from different types of sensors. The architecture was developed by ITTI of Poland and SAGEM of France.
Within the ARENA project, ITTI has developed a generic architecture which allows different sensors, such as CCTV cameras and thermal cameras, to be integrated on a single platform. The advantage of its architecture is its ability to scale to different number of sensors and its flexibility to deploy into different environments, such as land and maritime.
We at SAGEM implemented a key part of the architecture, the integration platform. The integration platform enables the communication between sensors and the different stages of information processing to ultimately determine if there is a threat to the mobile asset or not.
The first stage in the ARENA process is called object assessment, where objects are both tracked and recognised. In the case of a parked truck, for example, these objects could be people, or in a maritime situation, other vessels.
The University of Reading specialise in automated surveillance, mainly for public spaces. However, for the ARENA project, we have developed new methods for detecting objects, for example people and vehicles, in real time from multiple CCTV cameras as well as thermal imaging cameras, all of which are mounted on the vehicle itself. The detected objects are then tracked throughout the scene, and the classification of the object, for example whether it's a personal vehicle, as well as where the objects are relative to the truck, are then sent to the next stage of processing. The main challenge is to perform this task accurately when there are variations in the environment, such as changes in the lighting or the weather. The method must also be robust to changes in scene complexity, in particular the number of people and vehicles.
As well as the visual sensors, a face recognition scanner developed by Morpho can also be deployed specifically for the truck scenario. If the image does not match any authorised drivers held in a database, an alert can be triggered. The next stage in the ARENA process is called situation assessment. Its main task is to produce an intermediate understanding of the scene being surveyed from the object assessment information it receives.
We have developed a process called situation assessment, where we estimate the relations between the objects in the scene. We take single tracks from the individual cameras in the sensor network and fuse them into merged tracks. And we can reduce the number of false tracks, and we can also get more continuous tracks on the true objects. These merged tracks are input data to event recognition algorithms, and these can detect groups of people, the number of groups, the size of the groups and the density of the groups. And also we can detect the behavior of individual persons, such as the person loitering, walking, running, exiting, entering, attacking and so on. And this information about the events is given as input data to the threat recognition algorithms, which take place in the next process after the situation assessment.
We at TNO have been working on the threat recognition system within ARENA. We have as inputs the tracks from all the people walking around and from the behaviors of those people. And we try to combine it into a consistent picture. If you, for example, have somebody loitering at the smoking area, that's quite normal behavior. On the other side, if you see someone at a distance looking at the truck and he waits until the driver goes away from the truck. And at that moment, that person approaches the truck with an probably intent of a theft. At that moment, we want to raise an alarm and send it to the HMI of the ARENA system.
So the human-machine interface, or HMI, is basically a window into the onboard system. The system is doing a lot of processing to detect threats to the vehicle, and the HMI's primary purpose is to notify the human users of those threats. There are actually two HMIs which are developed in the project. The first was one which runs on a mobile phone, so we developed an Android application which is used by the driver. If the system on board the truck detects a threat or some suspicious behaviour, the driver's phone receives a message and also an image, and then the driver can either dismiss or confirm the threat and take appropriate action. The second HMI is designed for use in an office environment where an operator might be monitoring more than one truck which is using the ARENA system. So one of the windows in the interface is a list of all the trucks under protection, and if a threat or some suspicious behaviour is detected around the vehicle, the truck will start flashing either yellow or red for warning and alert, and the operator can then open another set of windows which shows more detailed information about what's going on. So there's an interface to view the feed from a specific camera, and the objects and tracks are overlaid on the image. And if the object is suspicious or threatening, it's ringed in either yellow or red. There is also a two-dimensional plan, like a map view, a kind of bird's eye view of the truck and the immediate surroundings, and the objects and tracks are marked around the vehicle on the map. And the third view is a kind of multi-camera view which shows all of the cameras simultaneously, and the operator can switch between the views to work out whether there is really a threat or not. So the system is ideal for maybe a trucking company or a private security company.
One of the key features of the ARENA system is its ability to be deployed in both land and maritime scenarios.
In the maritime scenario, we use the HMI to output the results of the tracking algorithms, just like we do in the truck case. In addition, we have two more sensors that we use for threat detection. In particular, that's radar, which is widely used on ships, and a thing called AIS, which stands for Automatic Identification System. And that's basically a text message a ship sends around saying, I'm here, this is my current position, this is my name, this is where I'm going. So what we do is, for our threat detection algorithms, we combine and fuse this information, and we're looking for inconsistencies between radar and AIS, and also for unusual maneuvering patterns. And if we detect any of these things, we can display it in the HMI and trigger an alarm.
The ARENA project culminated with a demonstration day at Safran headquarters in Paris to key industry stakeholders. It included the acting out of different scenarios based around a truck parked at a rest stop. The feedback on the technology on display was very positive.
A lot of highly valuable pharmaceutical and electronic shipments are moving around the roads of Europe by truck, and we've seen the number and value of incidents increasing in recent years, organised criminal gangs at work. So the sort of solutions that have been developed by the partners in the ARENA project will have a real commercial demand for them, not least from insurance companies as well as from haulage companies themselves.
Piracy is one of the big problems of the shipping industry at the moment, has been for a number of years now and will remain so, I would say, for a number of years. Difficult problem, it's a moving problem, it moves from area to area, and there are different types of piracy. Lots of solutions have been tried, none of them completely successful. I think it's going to take a lot of different solutions, and the ARENA system may well be one of those, may well contribute towards that final solution which everyone is looking for.
There is no doubt that in the future, the technologies developed as part of the ARENA project could be deployed in real-life situations and help to fight the increasing threats from organised crime, piracy and terrorism.